Okay, we're now doing section 3.4, the sine some angle identities. So sine 11 pi twelfths. We need to figure out how we can rewrite 11 twelfths. So let's think about 11 for a minute. 11 can be written as 6 and 5, but you want to think this in twelfths. 6 twelfths is good. 5 twelfths, not a unit circle. So let's try 6 and 5. How about 7 and 4? But again, 7 twelfths, no. How about 8 and 3? That works nicely. Think about it in twelfths. 8 twelfths divides nicely into, divide by 4, we get 2 thirds, and I can do 2 pi thirds. And then 3 twelfths is 1/4, I can do pi fourths. That's great. Had you tried one more, 9 and 2 works out as well, because 9 pi twelfths and pi 6, those would be working fine. But the first ones we got, let's go with sine of 11 pi twelfths equals sine, in parentheses, we rewrite 11 pi twelfths. Now 8 twelfths, again dividing by 4, is 2 thirds, so that's 2 pi thirds plus, and 3 twelfths is 1/4, so that's pi fourths. So 2 pi thirds plus pi fourths gives us 11 pi twelfths. Now the sine some angle formula is sine of x plus y equals sine x cos y. Same symbol, so plus. Now depending on the book, you can either see sine y cos x, or you might also see it sine x cos y plus cos x sine y. Really the same thing. That one and that one, they just reverse the orders. If you like the consistency of sine cosine, that's great. If you like the consistency of xy, that works as well. But the key thing is to remember that whatever symbol you have here, in this case plus, you have the same symbol over here, plus. So if this were minus, you'd have yours minus. Okay, now continuing on, we have sine of 2 pi thirds plus pi fourths equals sine of the first, cosine of the second, same symbol, cosine of the first, sine of the second. Now this simplifies. Sine of 2 pi thirds, that is second quadrant, sine is positive, pi thirds reference angle, sine is square root of 3 over 2. Cosine of pi fourths, that's the square root of 2 over 2. Plus cosine, second quadrant is negative, reference angle pi thirds, cosine is 1/2, negative 1/2, sine pi fourths, square root of 2 over 2. We can simplify this. Now the way the book has done this, they've actually, at least the solutions to this, not that it's that important, but square root of 6 minus square root of 2 is how I wrote one earlier in the review. If you notice, the square root of 2 is in common, so it's a greatest common factor. You can actually factor out the square root of 2. Now what this leaves is square root of 3 minus 1. This is how the key looks. It doesn't really matter, they're both fine. The square root of 6 minus square root of 2 over 4, and the square root of 2 times square root of 3 minus 1 over 4. It's just a matter of if you have a multiple choice test, then you want to make sure you have the correct one and you know how to go from one to the other. Okay, that's the end of this. Thanks. Right, another exact value. This time we're basing the tangent function. Let's write down the identity first off. 105 is not one I recognize. I could do a half angle and get to 210, but I don't know the half angles yet. But sum or difference, I'm thinking 105 is two things added up to 105. So we're doing the sum of tangent. So tangent sum angle, like tangent of x plus y equals. Now the identity is tangent x, same symbol, plus tangent y, divided by 1, opposite symbol, minus, and then the product, tangent x, tangent y. Okay, so for 105 degrees, now it ends with a 5, so let's think 105 is 45, most likely it's 45, that's the only nice angle on the unit circle that has a 5 in it. 45 plus 60, and those are both really nice unit circle angles. So the 5 gave this one away. It has to be 45, and then 60 is the other angle. So tangent of 105 degrees is therefore tangent of 45 degrees plus 60 degrees. And then we can use our identity, and it's tangent of the first, 45, same symbol, plus tangent of the second, tangent 60, all divided by 1, opposite symbol, minus the product, tangent 45 degrees times tangent 60 degrees. Now these are unit circle values, so it's just a matter of reducing them. For example, tangent 45 is 1, plus tangent of 60 degrees is, let's see, tangent sine over cosine. Sine of 60 has a square root of 3 on top, so that's all square root of 3. You might have it memorized. I think through it each time. It's all the same if you know the final answer. 1 minus 1 times square root of 3. So we have 1 plus square root of 3 over 1 minus square root of 3. And that's it for number 20. Okay, next question. Alright, this trigonometric identity, I don't know tangent 5, so I can't evaluate these, but I do recognize this is the sum angle for tangent. So we just went over this in the last problem. We know that tangent of x plus y equals tangent x plus tangent y divided by 1 minus tangent x tangent y. So this is almost exactly what we have. So recognize that the 5 degrees is x, 25 degrees is y, and the sign matches up with the plus. Everything's all set for us to go to that this is tangent of x, which is 5, same symbol on top, plus 5 degrees plus 25 degrees. That is tangent of 30 degrees. Now tangent of 30 degrees is 1 over square root of 2. Sorry, 1 over square root of 3. And then you can rationalize this depending on your book. You might or might not need to do this. It's easy enough. And with 1060 trigonometry, people usually do this without even writing the step anymore because it's so often that you have to do it. All right, that's this one. Alright, this looks like the sine cosine plus cosine sine. This is the sine x plus y. Let's write it again. Sine x plus y equals sine x cos y. Same symbol, plus cos x sine y. On this problem, we have x being pi 15ths and y being 4 pi 15ths, and notice the plus, so this is going to be a sum. Okay, so we have sine of x pi 15ths plus y 4 pi 15ths, and this equals sine of 4 pi 5 pi 15ths, which reduces to sine of pi thirds, which is a unit circle, square root of 3 over 2. That's it. Alright, next question. Alright, so once again, this problem, we're given information about cosine of an angle, and we're told where the angle is. In this case, it's quadrant 1. And B, information about it, and B is in quadrant 2. So we can take this information and create a quadrant 1 angle for A. Cosine is adjacent, 1 over hypotenuse, 3. There's cosine A equals 1/3. Pythagorean theorem, 3 squared 9, minus 1 squared 1, square root of 8, and that reduces to 2 square root of 2. Now this is positive. I know it's positive because up is positive and right is positive, and the hypotenuse is always positive. For B, second quadrant angle, we have sine is opposite over hypotenuse, 1/4. And therefore the adjacent 4 squared is 16 minus 1 squared is 15, square root of 15. This one is negative. Why it's negative is it's left. The one is up, positive, the hypotenuse is always positive. Now one thing that you want to look at, notice this B is in between pi halves. Here's pi halves, and pi, here's pi. So they're saying B is somewhere in between pi halves and pi, and I drew it right in the middle, right there. For A, between 0 and pi halves, and somewhere in between 0 and pi halves, I've drawn it here. I don't know exactly where it is, but it's not important so much where it is exactly as much as it's in the correct quadrant. Alright, we now have our angles set up, so we can now go to what they're asking for, sine of A minus B. Alright, now sine of A minus B, the formula is sine of the first, cosine of the second, opposite symbol or same symbol. For sine it's the same, so minus, and then cosine of the first, sine of the second. Now sine of A is opposite over hypotenuse, so we have 2 square root of 2 over 3. Cosine of B is adjacent over hypotenuse, so that's minus square root of 15 over 4. Minus cosine of A was given, but it's always nice to check your work. Cosine is adjacent over hypotenuse, and sine of B is also given, so these two are given. You might as well not think about them unless you want to verify your work. Sine of B 1/4. Alright, now the whole thing will be twelfths. There's nothing in common here and here, so there's no factoring that you could do. But what we do have is thinking in 15 is a 3 and a 5, and here we have a 2. There are no pairs, so that will not be able to be reduced. So we can just multiply and get 2 square root 30 and minus 1. Alright, now don't do something crazy like try to reduce this 2 and this 12. This 2 is part of a term, and terms don't cancel. If you wanted to divide this 2 out, you'd have to divide this by 2 and this by 2, but also this by 2, and that doesn't have a 2 in it, so there would be no good reason to divide. Okay, that's the end of this one. Alright, using a sum or difference identity expressed just in terms of functions of alpha. So right now it's a function of alpha plus 45, but we know our sine angle formula, so it's sine of the first, cosine of the second, same symbol, cosine of the first, sine of the second. And we can reduce cosine 45 degrees, square root of 2 over 2, and we put that first. Keep things in alphanumeric order. And sine of 45 degrees is also square root of 2 over 2. The answer key may well have these reversed, but it doesn't really matter. The only reason why they might is C alphabetically comes before S, and so if you stick to alphanumeric order, those are switched. I would never take credit off for this, and most computer programs wouldn't take any credit off for that either. And multiple choice, you just match it up. So I'm going to stick this answer right where it is. Okay. Alright, decide whether the expression is an identity or not an identity. Well, on the left side, I definitely recognize this as an identity I do know, and this one also is an identity I do know. So I'm going to start right there. And what I get out of this is this first one, that would be sine A cosine B plus cosine A sine B. Now be careful, that is all that one. It's multiplied by the next one. So this is all multiplied, and the next one would be sine A cosine B minus cosine A sine B. All right, this looks like a big mess. We're going to FOIL this because that's what you do with two binomials. We have two terms here and two terms here, so first, outer, inner, last, and here we go. First, I would get sine squared A cosine squared B. Now we're saved a little bit on this. I believe we have conjugate, so the inner and outer products will cancel, but let me demonstrate them. Outer product would be minus sine A cos A sine B cos B. The inner product here is going to be plus sine A cos A sine B cos B, and they do in fact cancel. And the last product is minus cosine squared A sine squared B. Okay, so once again, these cancel. They were conjugates, so we expected those to cancel. So now let's see, what do we have now? Let's rewrite it. Sine squared A cosine squared B minus cosine squared A sine squared B. Now, where to go, where to go, where to go? This does not look like where we're headed yet, for sure. It does have two terms, but this, where we're headed, does not have any cosines at all. And we have these cosine squareds. We have a very nice identity for cosine squared, specifically cosine squared x equals 1 minus sine squared x. We're going to use that. We're going to replace this cosine squared and this cosine squared with our identity. So this will be sine squared A 1 minus sine squared B. Since it was cosine squared of B, this is 1 minus sine squared of B. The next one will be 1 minus sine squared of A times sine squared B. Again, originally it was cosine squared A, and so it's 1 minus sine squared A. Alright, now let's distribute here. Right there. This will be sine squared A minus sine squared A sine squared B minus, now inside here, since it's subtraction and there's going to be two terms, I need to be very careful with the distribution of the sine squared, but then also the distribution of the negative. In fact, I think I'm going to do it in two different terms. Two different steps. So this would be inside sine squared B minus sine squared A sine squared B. And now distributing the negative, we have sine squared A minus sine squared A sine squared B minus sine squared B plus sine squared A sine squared B. And finally, we get these terms to cancel, leaving us with sine squared A minus sine squared B. This is where we're headed. This is an identity. And that was a long problem. Nice to have it done. Alright, determine if this is an identity. Now, there are no cotangent sum angle formulas. The right side looks kind of like the tangent sum angle formula, but that's going to be, this is probably our first really good challenge for an identity. What I'm going to do is I'm going to work on the left side, knowing the fact that cotangent of A equals cosine A over sine A. I can rewrite the left cotangent x plus y as cosine x plus y divided by sine x plus y. Now the whole point in doing this is because I know the identities for cosine some angle and some angle for sine. I don't know them for cotangent, although you can have those memorized. I'm going to show you, you don't need to. Alright, the basic identities. Cosine, cosine x, cosine y, opposite symbol minus sine x, sine y. Denominator, sine x, cos y, same symbol, plus cos x, sine y. Alright, good. So at least we're now into things we recognize. Taking again another look at this, where we're headed, look at the minus 1. We have the minus, but we have sine x, sine y. So here's the biggest hint of all. To make 1 out of sine x, sine y, we need to divide by sine x, sine y. But we have to divide everything by that. Sine x, sine y, this one, sine x, sine y, and this one, sine x, sine y. You might have seen that I just like pulled this out of my hat, but again, it's because I'm aiming for this in a minus 1. If I were to divide this right here, that one term is now minus 1. That's the only reason I did it. Let's take a look at what else happens. So in this first one, cosine x over sine x and cosine y over sine y, that would be cotangent x, cotangent y. Everything's looking great so far. The denominator, these cancel. That's cotangent y. So we have cotangent y plus, and these cancel, and that is cotangent x. Cotangent x. Wow, it wasn't as hard as I thought it was going to be. But that's only because I know what trail of breadcrumbs to follow. My first trail was, I don't know cotangent x plus y, but I know cotangent is cosine over sine, so I changed it to cosine x plus y over sine x plus y. I know those identities well. The next one, how do I make a 1 out of sine x sine y? Divide by sine x sine y, and it all just canceled out. So what we have here is this is an identity. All right, excellent. This completes this review.